Factory Insight welcomes you to the papaya belt of the future, where vast orchards of ripened fruit are
Sound, mature red papayas are carefully picked and trucked to this ultra-modern processing plant for pulp extraction. Here automation meets agriculture. Conveyors, sorters, and pulpers handle tons of fruit per day, ensuring consistent quality and high throughput.
From silky puree and tangy nectar to chewy dried snacks, this facility creates a spectrum of papaya products for markets around the globe.
Aseptic bags packed into metal drums can keep papaya puree fresh for up to 2 years, allowing safe transport across oceans.
Papaya's vibrant orange flesh is rich in vitamins and enzymes, making it a prized ingredient in beverages, desserts, and even pharmaceuticals.
To conserve resources, modern lines use low-temperature evaporators and recovery systems that improve product quality and reduce energy consumption.
Robots equipped with AI-driven vision systems handle sorting, lifting, and packing with precision, pushing efficiency to new heights.
A PLC-based control system records every temperature and flow rate, giving engineers a digital window into the entire production process at any time.
Join Factory Insight as we journey step by step through this future papaya factory, from washing and de-seeding to packaging and quality control.
In the receiving yard, crates of ripe red papayas are unloaded and visually inspected before entering the processing line.
The first step is washing. A bubble system agitates the fruit, while rolling brushes scrub away soil and debris.
Bubbles gently propel the papayas forward as brushes rotate against them, providing thorough cleaning without bruising.
After washing, used water is filtered and recycled, conserving resources and meeting environmental standards.
On the sorting belt, operators remove underripe or blemished fruit, while sensors flag size and color variances.
Machine vision complements human eyes. 3D cameras and lasers classify each papaya by size and ripeness for targeted processing.
Sorted fruit rides an elevator to the de-seeding stage, ensuring a continuous flow into the heart of the plant.
On a 3-level platform, workers halve the fruit and scoop out seeds. The upper deck receives whole fruit. The middle is for cutting and de-seeding. A de-stoning drum ensures that any remaining stones or seeds are removed, protecting downstream pulpers.
These extracted seeds are not wasted. They are collected for oil extraction or further processing into supplements and seasonings.
The de-seeded fruit is gently preheated to around 85–90 degrees Celsius to soften fibers and inactivate spoilage enzymes. The preheater's adjustable temperature control and automatic return flow function ensure uniform heating across the batch. After each batch, a clean-in-place spray bowl rinses the preheater's interior, keeping the system sanitary. Heated fruit mash flows toward the pulpers, its fibers loosened and enzymes inactivated for optimal extraction.
Even in an automated plant, human eyes confirm ripeness and quality. Future factories blend technology with craftsmanship.
Chlorinated water provides an extra layer of sanitization, reducing microbial load on the raw fruit.
From unloading to preheating, dozens of machines work in concert to deliver clean, de-seeded papayas ready for pulping.
With washing, sorting, de-seeding, and heating complete, the fruit is now ready for pulp extraction.
Pulping begins as the warmed fruit enters a double-stage pulper. Blades rated up to 114.7 RPM to specially designed rubber paddles force the mash through stainless steel screens, producing a smooth texture while minimizing seed breakage.
On larger lines, a crusher scraper removes edible pulp from the peel by sliding slices between a slow upper belt and a rapidly rotating scraping cylinder.
The scraping cylinder's stainless rods spin at roughly 1,200 feet per minute, about 4 times faster than the belt. The output is a slurry of peel, seeds, and pulp, which flows into the next piece of equipment for separation.
A continuously operating centrifugal separator spins at about 600 RPM. Heavy peels and seeds are flung up the basket.
To stabilize color and flavor, a 50% citric acid solution is metered into the puree.
The acidified puree flows into holding tanks, where mixers keep it homogeneous, and technicians monitor pH for accuracy.
Gillette, a final finisher equipped with a 0.020-inch screen, removes any remaining fiber or black specks.
The refined puree is sterilized or pasteurized in a tubular heat exchanger to to kill microorganisms before packaging.
Countercurrent heat exchange heats the puree rapidly and evenly, preserving nutrients while ensuring safety.
After heating, the puree enters a vacuum deaerator where dissolved gases are removed. This prevents oxidation and browning.
A homogenizer then subjects the puree to high pressure, breaking down particles to prevent separation and improve fineness.
For papaya nectar, strained puree is blended with water and sugar. A touch of citric acid balances the sweetness before pasteurization.
Variable speed agitators ensure ingredients dissolve uniformly while minimizing foam.
To produce concentrate, the puree enters a falling film evaporator. Under gentle vacuum, water is removed and the product thickens without scorching.
Low-temperature evaporation preserves color and flavor, improving product quality.
A PLC control system logs process data and triggers alarms if bricks, pH, or viscosity stray from set points.
During delicate operations, inert gas injection protects the puree from oxidation by displacing oxygen.
After every roux, an automatic sip system circulates detergent and sanitizing solutions through every pipe and pump to ensure hygienic conditions. Beyond puree and nectar, thin slices become chewy, dried snacks as they pass through low-temperature dehydrators.
Multiple syrup infusions allow the cubes to absorb flavors and color, resulting in a jewel-like candy. Tutti. For petha, peeled papaya segments are firmed in lime water, then simmered in increasingly concentrated sugar syrup until they become translucent treats.
Unripe papayas are scored early in the morning, and latex is collected for papayan extraction, a proteolytic enzyme used in food and medicine.
The latex is dried, ground, and standardized. Proper maturity and careful drying conditions ensure high enzyme activity.
Papain's ability to break down proteins makes it invaluable for meat tenderizing, beer clarification, wound care, and cosmetics. Separate lines produce papaya nectar by pulping, straining, and blending with water and sugar before pasteurization.
Inline sensors continuously monitor sweetness, thickness, and temperature, adjusting valves to keep the product within spec.
In vacuum evaporators, water is gently removed, producing concentrate with uniform consistency and intense flavor.
Engineers use real-time data to tweak parameters, ensuring low-temperature evaporation improves quality and reduces energy use.
Inert gas injection keeps oxygen away from delicate flavors, preventing oxidation during mixing and holding.
CIP skids store detergent, rinse water, and sanitizer, automatically sending each solution through the plant to achieve a thorough clean.
Future factories use modular units that can process 20 to 100 tons per day and can be reconfigured quickly for new product lines.
AGVs ferry heavy drums and totes across the facility without human assistance, improving safety and efficiency.
Before each production run, instruments are calibrated to ensure pH, sugar content, and viscosity readings remain accurate.
After a series of sophisticated steps, pulping, refining, acidifying, deaerating,
Beyond beverages, some batches become papaya jam. Puree is cooked with sugar and spices until it reaches a thick, spreadable consistency. Collected seeds are washed and dried to be pressed into papaya seed oil, an emerging culinary and cosmetic ingredient.
After syrup infusion, candied cubes are coated in sugar before being dried to lock in sweetness and color.
For fruit leather, puree is spread into thin sheets and dried under carefully controlled warm air until flexible and chewy.
Robots slice dried fruit leather into strips and roll them neatly for packaging, maintaining consistency at high speed.
In R&D labs, food scientists develop new papaya products, balancing flavors and experimenting with novel processing techniques. Overhead walkways provide safe observation points where engineers can monitor operations and make real-time adjustments. From jam, nectar, and dried snacks to medicinal enzymes, this futuristic factory maximizes the value extracted from every papaya.
Just before filling, the puree passes through another sterilization step to ensure aseptic conditions for packaging.
Septic fillers deposit the hot puree into pre-sterilized bags housed within drums. This closed system preserves shelf life for up to 2 years.
The polyliner is sealed using heat and pressure, then cap it with a metal lid to protect the sterile contents.
Each drum is weighed and labeled. Barcodes track batch numbers, production dates, and destination. Separate lines produce bottled beverages. Containers are sanitized with sterile air before being filled and capped at high speed. Vertical form-fill seal machines form pouches from film, fill them with dried papaya slices, flush them with inert gas, and seal them tight. Inert gas replaces oxygen inside snack packages, preventing oxidation and keeping dried slices crisp for months.
Metal detectors and magnetic traps remove any foreign objects, ensuring that only safe, contaminant-free packages leave the facility.
Filled drums are automatically wrapped and stacked on pallets, ready for cold storage and international shipment.
Labels list ingredients, nutritional facts, and warnings to comply with food safety regulations and inform consumers.
Candied cubes are packed into jars, capped, and fitted with tamper-evident bands to maintain freshness and safety.
Modular packaging lines allow the plant to produce diverse products side by side, each with its own sterilization and sealing requirements.
Every package is scanned and logged into the production database, enabling full traceability from orchard to customer.
Logistics extend beyond the factory. Refrigerated trucks and container ships carry papaya products across continents. Dispatch teams coordinate deliveries using real-time tracking data, ensuring that customers receive fresh products on schedule. Critical parts of the filling system are sterilized with UV light between batches to maintain aseptic conditions.
Packaging materials are recovered and recycled whenever possible, minimizing the environmental footprint of papaya processing.
With sterilization, filling, and packaging complete, the fruits of this futuristic factory await their journey to kitchens around the world.
Sensory panels evaluate color, flavor, and texture, complementing instrument measurements with human perception.
After each run, the line is hosed down, scrubbed with detergent, sanitized with chlorine, and disassembled for thorough cleaning.
Operators follow strict sanitation checklists, logging cleaning times and verifying that every valve, plate, and pump has been sanitized.
Sustainability is integral. Low-temperature evaporation, CIP water recycling, and the conversion of peels and seeds